So we have our 5 blocks. We relabeled A, B, C, D, and E. And we've also assigned a distribution on each one of them. So A was a Weibull function, B, C, D are a log normal distribution, and block E is an exponential distribution. So now we want to configure them to represent our complex system made out of 3 blocks in parallel and with the voting criteria, followed by a block E in series. So one of the fundamental aspect of reliability block diagram, we have to have a starting point. In this case we have a block A as a starting point and one end point. So there has to be one start point and one end point. So we're going to connect our blocks. From A we go to B, and from A we go to C and to D, and then we come out of these blocks and we go into the node. And we'll notice as we go into the node the number changes. And the number changes because it reads how many lines are going into the node. So it reads 3 lines, and then it's up to us to define the criteria. By default it sets 1 out of 3 or 1 out of n blocks, and it's up to us to decide whether we want to change this criteria. So if we want to change that criteria, we go on the node, double click, and say for example we want a criteria 2 out of 3. So we look at the number of paths required and we put 2. And so we click OK. So now we got the criteria of 2 out of 3. So block B and C have to be active, and block D can fail, or any other combination. Say block B and D can work and block C can fail. But we need at least 2 blocks operating for our system to operate. And obviously we need block A and E as well. So we want to rearrange them. And now we're ready to analyze. So we're ready to analyze, and we click on calculate. And then we want to look at the graphs. We've got various graphs. Starting from the first one, under system, we look at the unreliability of our system. So we looked at the probability of failure of our system, how this probability of failure changes in time. The second graph is the reliability. Reliability is a function of time. And as you can see, as we move the cursor on top of the line, we can, and you click on it, we can latch onto this line, and then we can move it and see how the reliability changes as a function of time. But if we want to take a more accurate measurement, because it's not that easy to just position the cursor in a specific point, we can use the quick calculation pad, or QCP. We can clear anything that's there before and say we want the reliability at 1500 hours, for example, and we click OK, and we have 12% reliability at 1500 hours. And the QCP gives us quite a range of information: reliability, probability of failure, conditional reliability or conditional probability of failure, or information where instead of probability we actually get lives. So the input will be a probability. In this case we'll have reliable life, BX life, or mean life, for example, and the last one is a rate, and it's a failure rate. So we can get a lot of information from our QCP, like we can get a lot of information out of our graphs. So for example, if we are interested in seeing the failure rate of our system, we can see the increase in failure rate of our system. And if we want to look at the specific details about the blocks, we can go on to this category, blocks, and perhaps select reliability of the blocks. And here we can see the reliability of block E against the reliability of block B, C, and D, which are all the same value, therefore there are 3 lines one on top of the other, or the reliability of block A, or the reliability of the entire system. So what we can see with this very quick series of video, we can see how we can create a very simple system, load some data, and analyze our results with BlockSim. In the following video we'll be able to see other important features of this package.